Hello everyone, this is Simple Math for you. Today we are going to revise two lessons. Lesson 5.3, scatter plot and lines of fit, and the other lesson will be 5.4, correlation and causation. Let's start. We are going to solve some questions. Consider these scatter plots. We have scatter plot A, scatter plot B. Scatter plot A shows a positive, negative, or no correlation. It's very obvious here that the trend of the dots or the points is going down, it's decreasing, so it is negative correlation. So we are going to choose B. While in scatter plot B, the trend is going up, it's increasing, so the scatter plot B is showing a positive correlation. Positive correlation, this is positive. Negative correlation when it's decreasing, and if it is scattered everywhere, it is no correlation. Match each scatter plot to its description. Let's see now. It's very obvious that the positive correlation is shown by C, it's increasing, while B shows negative correlation and A shows no correlation. It is just going unstable. Match each scatter plot to its description. Negative correlation is C and positive correlation is B, while A has no correlation. Determine which plot has the best line of fit of the scatter plot. Let's remember what is the best line of fit. The line of fit, or the best line of fit, should pass with most of the points. If not, then the number of points above the line should be approximately equal to the number of points below the line. So here, for example, let's see this line. In this line, as you see, there are lots of points below the line. Yes, it is passing by 3 points, but the number of points below is 4, while there is no points above. So I don't think it is best line of fit. Let's check B. B is passing through 2 points, and we have 1, 2, 3 points above the line, and we have 1, 2, 3 below the line. Approximately, you can say it's fair, so it is a good line of fit. Let's see part C. In part C, it is passing through 4 points, yes, but as you see here, we have 1, 2, 3 above the line, while we have only 1 point below the line, so it is not a good line of fit. Let's see question 5. Use the scatter plot to complete the statement. Line A or B represent the better line of fit in the scatter plot. So we'll choose which one is better, line A or line B. Let's check. For line A here, if you ignore line B, as if this is not here, as you see here, it is passing through 3 points, while we have 1 point above. How many points below? 1, 2, 3, 4, 5 points below, which is not fair. And that means line A is not the best fit. Let's move to line B to analyze it. Line B is this line. Line B is passing through, doesn't pass through any point actually, but let's see, we have here 4 points below the line, and we have here 5 points above, so approximately they are equal, and we can see they're not equal, of course, but it's fair, kind of fair. So that means line B is a good line of fit. It's a better line than the line A. Which equation represents the best line of fit? Remember, when we are asked to find the equation, it should come to your mind y equals mx plus b. So we need the slope, but we don't have a line. So first we need to draw a line that is the best fit. So let's try to draw a line somehow in a good way, we can say. Okay, let's say that this is a good line. Yani it's midway between the points. And as you see, I can see that this is a good line. Actually, for these kinds of question, we cannot find all of us having the same answer, unfortunately. Yani. So in this case, we will try our best to have approximate answer. This is considered a good line of fit because number of points above this line is 1, 2, 3, 4, and number of points below the line. Okay, let's go back. Okay, kind of, I changed a little bit. Okay, and number of points below the line is 4 points, so it's a good line. Now we want to find the slope of the line. To find the slope of a line, we need 2 points on the line. So let's choose 2 points. This is one of the points, and we can say that this is another point. If you want to find the slope, remember the slope is rise over run. So we are going 2 units down. So it's -2, and we have 3 units to the right. So it's -2 over 3. Of course, you can find the coordinate of this point, and apply the slope formula, but I like to use the rise over run. If you find this, -2 over 3, it's approximately -0.6666, which is approximately -0.7. You should know that this line has a negative slope. It's decreasing. And as you see here, the only line has -0.7 is B. And actually, if you see that this is y-intercept, so it is approximately 7, 1, 2, 3, 4, 5, 6, 7, less than 7. So it's a good approximation. That means this is our equation. What is the approximate slope of a line? Same here. We need to find the best fit first. So let's try to draw a line that is good line of fit, we can say. We are trying our best to be as much as accurate as we can. If we start doing finding the slope here, let's take 2 points. If you take these 2 points, we will find that the slope is positive first, it's not negative. And according to my line, it is 3 over 3, so it's 1. The nearest value is 0.7. Of course, you can find it in a good way, in a better way. You can find 0.8, 0.75, but it's the good approximation of the slope. Now, is this line drawn on this scatter plot is a best fit? Why or why not? Actually, as I said, as mentioned earlier here, we can see that this line is passing through 3 points, and most of the points are above the line. So I don't think it's a good line of fit, best line of fit. No, it's not the best, because number of points above the line is much more than the number of points below the line. I hope it's clear now. The scatter plot shows the number of workers employed in the rail transportation industry from 1990 to 1997, according to the Bureau of Economic Analysis. So according to this figure, the scatter plot shows positive, negative, or no correlation. It is very clear here that trend is decreasing, right? It's slightly decreasing, but it is decreasing. So it has a negative correlation, and we can say that the number of employees was generally decreasing. As X increasing, the Y decreases. تقل الواي. Number of employees is decreasing يقل. Now let's move to this question. So another real ref application. The table shows the average length in minutes of professional baseball games in selected years. Okay. This is the table. Make a scatter plot and draw a line of it. For this scatter plot, actually, we will not need 4 quadrants. We will need only 1 quadrant, which is the first one. So I will change the axis. It will be this one. We will ignore this and that. We only need the first quadrant since all the values are positive, either x or y. Now we have to choose a good scale. Now the minimum value of y here is 169. The maximum is 189. So I will mark this as if we are going to start with 165, and I will add 3. I will choose a scale of 3. So I will add 3 at every time. 177, 180, 183, 186, 189, and 192. I think it's enough. For the x-axis, it starts with 2005. Usually the time, the year, and the time, we will use the x-axis here. So it is here the year, while here is the time in minutes. Usually the first one is x and the second one is y. Right. We are starting by 2005. So same here, I will do this mark, and I will start by 3, 5, 7, 9, 11, 13, 15, 17, 19. يعني every time I will add 2, odd numbers. I can also start normally without this mark if you want. I can start by 1, 3, 5. Okay, let's go back to this better. This is a good one. No need to change it since we have done it. Let's now try to plot the points. The first one is 2005 with 169. So I'll assume this is the 5 with 169. This is 168. So it's a little bit up. It's somewhere here. The other one, 2007 with 175. So 7 with 175, somewhere here. The 2009 is exactly the same. 2011 with 176. So little less than 177, little increasing. 2013 with 184. And 2015 with 180. It's little decreasing again. 2015 with 180, somewhere here. 2017 with 189, it's increasing again. I'll make it a little bit darker so that you can realize how the scatter plot looks like. As you see here, the trend is increasing, so it shows a positive correlation. Good. And we will draw now a line of fit. So let's try our best to draw a line of fit. So the line of fit here, we can pass somewhere like this. I think it's a good one here. Okay, almost there. This is a line of fit. Now, if X represents the number of years since 2005, then year 2005 is represented by X equals to 0. Remember that we will take this year as 0. The first one is 0. Everything will refer to 2005. It means 2020 will be at X equals 15. So X equals 15 means what? 2020 minus 2005, because this is our 0. So X will be 15. Remember this because we are going to use it later. Find 2 points that are on the line of fit and use them to find the equation of line of fit. Of course, now each one will have different slope. So in this case, we try to find the best points. Now he has chosen here 2 points so that we are all unified, having the same equation of a line. As usual, if you are asked to find the equation of a line, we need the slope. So we will apply the slope formula, which is y2 minus y1 over x2 minus x1. This is x1, y1, x2, y2. So 189 minus 175 over 12 minus 4. This is equal to 175. Now, how can we write the equation of a line? We know that y equals mx plus b. We can use the first point. So 175 will be our y. 175 is the slope times x, which is 4 plus b. And then when you multiply 1.75 times 4 is 7. Taking the 7 in here, so b is 175 minus 7, b is 168. And now we need to write the equation 175x, our slope, plus the new b, which is 168. This is the equation of a line. Now, why we are creating the equation of a line? To be able to predict the next years. Now here we have only the statistics until 2017. So if we are asked to find the next years, we can find that using this equation. If the trend continues, what will be the approximate annual length of a Major League Baseball game in 2021? For 2021, we have to subtract 2005 because this was mentioned to be our reference, and it will be 16. So that means we have to replace with x equals to 16 here in this equation. So it will be y equals 175 times 16 plus 168. The total will be 196, and that means we have 196 minutes. Approximate length of a Major League Baseball game in 2021 will be 196 minutes. Now, part D, how reliable is the predicted length of a Major League Baseball game in 2021? How reliable means, can we rely on, can we depend on, can we trust this result? هل نثق فيها؟ هل موثوق في هذه النتيجة? Of course, it's not that much reliable because not all of the data points are close to the line of fit. So there is not consistent trend regarding the length of the games. That means we may or may not rely on the predicted length on this result because not all of the data or the data are close to the line that we have graphed. That was all the revision regarding the first lesson about scatter plot, and now we are going to move to the correlation and causation. Correlation, we have an idea about correlation. It can be positive, negative, or no correlation. But now we are going to relate it what we call causation. Causation means like a reason. Is X the reason of having the Y? Is it the result of having the Y? And we will explain that in these examples. A strong positive correlation between two variables always, sometimes, or never indicate causation. It's sometimes because not all the correlation is a cause and effect. Not each X is a cause of Y to happen. Let's see number 2, determine whether each situation illustrates correlation and causation, correlation but not causation or neither. Let's see number 1. A student created a scatter plot comparing height and shoe size. This is the height of the student and his shoe size. The data shows an increasing trend. Okay, after the statistic we show the increasing trend. So it is definitely correlation, and it is positive correlation. Yes, but is it causation? Means, is the shoe size, or does the shoe size cause the height to be higher, or vice versa? Is this directly relating to that? Can we expect that as much as your shoe size is more, that means your height should be more? Of course not. So it should be correlation, but not causation. Now let's go to number 2. A student created a scatter plot comparing shoe size and now grade point average. Your average, your score, A, B, C, D, معدلك. So here the data showed random arrangement of points. Since it is randomly arrangement, so أكيد, of course, it is no correlation أصلا. So since it is no correlation, that means it is أصلا not causation. So remember, when it has no correlation, of course, it will be not causation. 3. A student found no noticeable relationship. لا يوجد أي علاقة ملحوظة بينهما. So it could be also scattered everywhere. It could be like this. Whatever it is, the reason, يعني. The number of our students spent exercising and student grade. Also, it is the relation between time of exercising and the GPA or the scores. So since it is scattered everywhere, so it is neither correlation nor causation. Now moving to 4, Jamal noticed that his favorite baseball team was more likely to win when he wore a certain hat. So yani, it is like a kind of luck, and it is by chance. It can happen by chance also. No, that means here wearing number set, yani all مثلا the team players wearing certain hats, then it is showing that it is increasing somewhere, the possibility of winning. But do you think that wearing specific hat causing the team to win? Of course not. This is not the main reason of win. Winning means exercising, means more time to be spent on practicing, but it's never depending on wearing a certain shoe or a certain sock or a socks or certain hats. So that means, yes, it can be correlation. Here, where is that? Certain hat. So it can be, we said yes, correlation, but not causation. Yes, because he said that there is more likely. So here we are. Here I got lost. Correlation, but not causation. Now, 5. A study found that there is a positive correlation. So we have here. Let's try to find here positive correlation between what and what? Weekly time spent studying. So it is a relation between a study time and grade point average, your score. It's most likely, yes, of course, when you study more, you are possible to get, it's possible to get good grades. So your GPA will be better. So it is definitely correlation. Aslan, he mentioned that it is increasing. Oh, it is positive correlation. So it is correlation and causation. It's both correlation and causation. The first one, we have both now. For 8 weeks, student kept track of time he spent studying each week. So we have here a relation between study time, and the weekly algebra quiz scores in algebra. Then he plotted the variables on a scatter plot and noticed that the points generally fell down a straight line. Of course, we should expect that it is increasing and it is about to be a straight line. So it means yani, as long as you study more, then you expect better scores. What type of relationship most likely exists between the two variables? Of course, it will be correlation and causation. It is positive correlation and it is causation. Yes, it is depending on that. Getting better scores depend on how much time you study. Of course, it's effective studying, not just time of looking at the videos of algebra. Okay, here a study of 100 randomly selected students from 1st through 6th grade finds a strong correlation between overall fitness and participation in sports. So we have fitness and participation in sports sport exercises or something like that. So it's most likely to increase. Can you conclude that participation in sport causes students to be more fit? Of course, yes, common sense. Participating in sports requires exercising, while likely causes students to be fit. So participating in sports requires exercising. It means more fit, being more fit. So most likely it will be correlation and causation. Okay, let's see. Next one. A salesperson at a department store notices a strong negative correlation between the daily sales of raincoats, so negative correlation between raincoats and swimsuits. So here, raincoats and swimming suits. Okay, to increase the number of swimsuits sold, he believes that the store should stock fewer raincoats. Is this reasonable conclusion? Yani, what does he mean? He means that buying swimming suits will depend on buying raincoats. Okay, there is a correlation, yes, because buying swimming suit means the weather is hot, while buying a raincoat means the weather is cold and it's rainy. Yes, there is a negative correlation between them, but this does not depend on that. Buying swimming suit will not depend on buying raincoats. So it is correlation, but not causation. So both raincoat sales and swimsuits are likely correlated to rainy and sunny days, but it's not causation. They are not depending on each other. So the answer is no. This is correlation, but not causation. Because buying, you can say buying buying raincoats does not depend on buying swimming suit. Okay, consider this scenario. Identify the sentence that is not mathematically accurate. I can change the question, for example, also in one of the exams to be identify the sentence that is accurate. We can say that here also. Same, you have to read carefully. The principal of a school wanted to compare pet ownership امتلاك الحيوان الأليف and student grades ودرجات الطالب. She made a scatter plot comparing the number of pets and grade point average. So there will be like a scatter plot comparing the number of pets and the GPA score. The data were arranged in an increasing trend. It was increasing, not necessarily a straight line, but it is increasing. The principal concluded that there was a positive correlation because it is increasing, so it's positive correlation between the number of pets owned and average grades. Because of the positive correlation, the principal believed that owning pets caused higher grades. Yani he said, or she said that it is causation. Yani buying pets or owning pets causing your grades to be high. Let's see each statement. She made a scatter plot comparing number of pets and grade point average for each student. Yes, she did. The data were arranged in increasing, yes, they were arranged in an increasing pattern. The principal concluded that there was a positive correlation. Yes, she did. Now, because of the positive correlation, the principal believed that owning pets caused higher grades. Of course not, this is wrong. This is wrong. So we have to choose this and we have to ignore that. Yes, Of course, yes, it is positive correlation, but it is not causation. Fatma weighs each type of fruits her garden produces each week. We have a table showing that, and we need to graph the order pairs. Okay, let's see now if we graph them. We have here the relation between strawberries and blueberries. So we can here have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Of course, we also will need the first quadrant. We will not need all other. Okay, and the blueberry is 6, 5, blah, blah, blah. The maximum is 6, so we can say 1, 2, 3, 4, 5, 6 normally. Let's try to plot. The first relation of the first order pair is 6.5 with 6. So this is 7. 6.5 will be somewhere here with 6. And then we have 8 and 5. 8 and 5 here. Then 12 and 14.5, 4.5, sorry, 12, and this is 4 somewhere here. Next, we have 13.5 and 3. This is 13, and this is 13.5. So we were here, somewhere here. Then 20 and 2.5. This is 20, and this is 2, 2.5, somewhere here. This is called the scatter plot. Does the scatter plot show a positive, negative, or no correlation? As you see here, as the number of ponds increase, we notice that the number of blueberries, ponds of strawberries, increase, it is decreasing. So it is kind of decreasing, somewhere decreasing, something like that. Yes. So it is decreasing. We have decreasing means it is negative correlation. Determine whether the data illustrates a correlation or causation. What other factors may influence the data? Yes, it is correlation here. Correlation. And we notice that it's negative correlation as well. What other factors may influence the data? Other factors, it's not causation. Why not causation? Because a better yield of strawberries does not cause the blueberries to grow poorly. For example, if we have better, this is what? This is strawberry. Yielding or producing strawberries does not cause that this one will be less. This is blueberry, this strawberry, and this is blueberry. This is not depending on that. So it seems that it is correlation. It's very obvious that it's negative correlation, yes, but not causation. Other factors can affect or influence the relation, like temperature, rain, and any other factor. With that, we are done, like a quick revision for the scatter plot and the correlation and causation. Thank you. Goodbye.